Welcome back to my channel Knowledge Chronicle.
Every breath we take is an incredible process that fuels our body with oxygen and removes carbon dioxide. But have you ever wondered how this exchange of gases happens? Today, on Knowledge Chronicle, we'll explore the fascinating journey of air through your body, and how oxygen reaches every cell while carbon dioxide is expelled. Breathing starts with the diaphragm, a dome-shaped muscle under the lungs. When it contracts, it creates a vacuum that pulls air into the lungs. The air travels through the nose or mouth, down the trachea, into the bronchi, and finally reaches thousands of tiny sacs called alveoli, where gas exchange takes place. When we exhale, the diaphragm relaxes, pushing carbon dioxide out of our body. Now let's dive into the details of gas exchange inside the alveoli. Alveoli are surrounded by tiny blood vessels called capillaries, which allow oxygen to pass into the blood and carbon dioxide to move out. This happens through a process called diffusion, where gases move from areas of high concentration to low concentration. Oxygen moves from the alveoli into the blood, while carbon dioxide moves from the blood into the alveoli, ready to be exhaled. Gas exchange is driven by partial pressure, which is the force that gases exert in a mixture. It is measured in millimeters of mercury and is written as PO2, partial pressure of oxygen, PCO2, partial pressure of carbon dioxide. The movement of gases follows this pattern. Oxygen moves from alveoli to deoxygenated blood, and then from oxygen-rich blood to tissues. Carbon dioxide moves from tissues to blood, and then from the blood into the alveoli to be exhaled. Carbon dioxide is 20 to 25 times more soluble in blood than oxygen, which allows it to diffuse faster across the membrane, even though oxygen is more crucial for survival. For oxygen and carbon dioxide to move efficiently, they must cross a thin diffusion membrane, which has three layers. 1. The thin squamous epithelium of alveoli, the delicate lining of air sacs. 2. The endothelium of capillaries, the thin wall of blood vessels. 3. The basement membrane, a supportive layer between them. Despite having three layers, this membrane is less than a millimeter thick, allowing gases to move quickly. Oxygen needs a carrier to travel in the blood. This role is played by hemoglobin, a protein found in red blood cells. Hemoglobin binds oxygen in the lungs and releases it when it reaches body tissues. Without hemoglobin, the blood would carry very little oxygen, making life impossible. Carbon dioxide is transported in three ways. 1. Dissolved in plasma, which is about 7 to 10%. A small portion dissolves directly in blood. 2. Bound to hemoglobin, which is 20 to 25%. Carbon dioxide attaches to hemoglobin differently than oxygen. 3. As bicarbonate ion, which is 70% carbon dioxide, reacts with water to form bicarbonate, helping maintain blood pH. When carbon dioxide reaches the lungs, it converts back into gas and is exhaled. The table below shows the partial pressures of oxygen and carbon dioxide at different stages of gas exchange. Atmospheric air. Oxygen is 159 millimeters of mercury, and carbon dioxide is 0.3 millimeters of mercury. Alveoli oxygen is 104 millimeters of mercury, and carbon dioxide is 40 millimeters of mercury. Deoxygenated blood, entering lungs. Oxygen is 40 millimeters of mercury, and carbon dioxide is 45 millimeters of mercury. Oxygenated blood, leaving lungs. Oxygen is 95 millimeters of mercury, and carbon dioxide is 40 millimeters of mercury. Tissues, body cells. Oxygen is 40 millimeters of mercury, and carbon dioxide is 45 millimeters of mercury. This shows that oxygen moves from the lungs to the blood, and from the blood to tissues, while carbon dioxide follows the opposite path. Several factors influence how well oxygen and carbon dioxide move in the body. Solubility: carbon dioxide diffuses faster than oxygen due to higher solubility. Membrane thickness. If the membrane thickens, as in pneumonia, gas exchange slows down. Surface area of alveoli. More alveoli mean better oxygen absorption. Diseases like emphysema destroy alveoli, reducing gas exchange. Disruptions in gas exchange can lead to serious health issues. High-altitude oxygen levels are lower, making breathing harder. Lung diseases like asthma or COPD, airflow is restricted, leading to oxygen deficiency. Carbon monoxide poisoning. Carbon monoxide replaces oxygen in hemoglobin, starving the body of oxygen. Your lungs, blood, and heart work in perfect harmony, ensuring oxygen reaches every cell and carbon dioxide is removed. So, the next time you take a deep breath, remember the incredible science behind it. Your body is constantly working to keep you alive, one breath at a time. If you found this video helpful, don't forget to like, share, and subscribe. Your support helps us create even more valuable content. Stay curious, stay healthy, and keep breathing.